Hi everyone, I'd like to spend this episode fixing some problems and making a few small optimizations. So first of all, if I enter play mode, I immediately get this property to ID can only be called from the main thread error. So if we click on that to get some more info, we can track down this problem. It's originating with this material.setFloat call in the texturedata.updateMeshHeights method, and that is being called in the mapGenerator.generateMapData method at line 130. So let's head right over there. MapGenerator, line 130, we can see this updateMeshHeights call. And if we just head over to that method, we can see that there are indeed these two setFloat calls. And so those are causing an issue when we try and call them from a separate thread. So we're going to have to move this updateMeshHeights call to somewhere on the main thread. So let's cut that out here, and I'll move it up to the top of the drawMapInEditor method. And then we'll also want it to be called at the start of the game, so we can just create a awake method and call it there as well. So if we save this, and just clear that and enter play mode, it is now working correctly. Alright, so we've now got it working in play mode, but if I actually try and make a build of the game, so I'll quickly go into the build settings, just add the open scene and build, it's going to fail, and it will give us this error saying that the name Unity Editor doesn't exist in the current context, and this is coming from the updatable data script. So it's basically unhappy that we're using the Unity Editor namespace outside of a editor script. So we need to tell it to only compile this code containing the reference to the Unity Editor namespace if we're inside the Unity Editor. If it's for a standalone build, then it can just go ahead and ignore this code. So we do this using what's called a Preprocessor Directive. We say #if Unity Editor, and then all this code goes in there, and then #endif. Alright, so now this code will only be compiled if we're inside the Unity Editor. Now, this will lead to another problem in the noise data script. So let me just head over there, noise data. This has got a protected override void on validate, but if we are compiling this outside of the Unity Editor, in other words, for a standalone build, then this method won't exist, in which case this override won't make any sense, since there'll be no method for it to override. So we must also just add that same if condition here, only compile this if we're in the Unity Editor. Alright, and don't forget the endif. Okay, so if I save this now, and let me just clear these errors, can go build settings, and I'm just going to quickly set it so that the default is not full screen. I'll set it to be 1280 by 720. Disable the resolution dialog, and I'm just going to turn off the splash screen. That one. Alright, so before I build this, I just want to make sure that this rigid body is a little bit higher up. Alright, just so that it doesn't go through the terrain while it's still busy generating. And then I'll hit build and run. So just wait a moment for this to complete. And any second now, it should be popping up. And much to my horror, the terrain is completely grey. So that means that I have forgotten something. Alright, so since we don't have any of these onValidate callbacks inside of the standalone build, we need to go into the map generator, and in the awake method, we need to apply all of the information to the texture data. So we can just write texture data.apply to material and pass in the terrain material. Alright, I'm very quickly going to build this once more, just with Command B. And this time round, we have all of our pretty colors. Okay, so now that things are actually working, I'd like to focus a little bit on optimization. So if you do a bit of profiling, you'll quickly see that the biggest sort of performance hit comes from the generation of the collider. So if we just dig down here, you can see that a lot of time is going into the baking of the PhysX collision data. So that's where we want to be focusing our efforts. And the main approach we'll be taking is simply to ensure that we only create the collider if the player is about to step on to a new chunk. In other words, we only want to generate the collider if we're sure it's actually going to be used. Okay, so we'll get to that in a moment. I just want to quickly change how one selects which level of detail is used for the collider mesh. Currently, you can select one of these checkboxes, but I find it a little bit clumsy the way I've set this up, because you can have multiple selected or you can forget to select any. So I'd much rather just have a single int at the top here, just to set the level of detail index that you want to use. So let's go into the endless terrain generator here, and I'm going to create a public int collider level of detail index. We'll then want to pass this value to each of the terrain chunks that we create. So let's add it into the constructor call here. I'll add it just after we pass in the detail levels. So collider level of detail index, and we have to add that, of course, to the constructor itself. I'll add it here, int collider level of detail index, and we can now replace our collision level of detail mesh object just with int collider level of detail index, and we'll set that saying this dot collider level of detail index is equal to the value that we were given. Okay, so we no longer need to set the collision level of detail mesh. And down here in the update terrain chunk method, where we are actually assigning the collision mesh, I'm just going to delete all of this code for now, because we're going to be changing the way that works a little bit. We're actually going to have a separate method for it, a public void update collision mesh. And the reason we're having two separate methods is that this update collision mesh is going to be called much more frequently than the update terrain chunk method. And the reason for this is just that since we want to leave the creation of the collider as late as possible, for the reasons I mentioned earlier, we need to check the player's position every time he moves, otherwise we might be too late to create the collider, and the player will of course fall through the terrain. So we'll be calling this from the endless terrain update method, and we'll call it every frame so long as the viewer has moved. So we'll just say if viewer position is not equal to the viewer position old, then we want to go through all of the currently visible chunks. So for each terrain chunk in the visible terrain chunks, we'll say chunk dot update collision mesh. Okay, and then up here I want to create a constant float to determine how close the player has to be to the edge of the terrain chunk before it will actually create the collider. So let's say collider generation distance threshold, something like that. And I'll set that maybe to 5. And then in the update collision mesh method, we can start by saying float square distance from viewer to edge is equal to bounds.square distance given the viewer's position. All right, so if that square distance is less than our collider generation distance threshold, which we'll have to square since the viewer distance to edge is squared, so just multiply that by itself. If that's the case, then we'll want to set our collision mesh So we can say mesh collider.mesh is equal to level of detail meshes with an index of collider level of detail index dot mesh. Now, of course, we can only do that if that level of detail mesh actually has requested and received a mesh from the mesh generator. So we should do a check first by saying if level of detail meshes with our collider index, if that has a mesh, only then will we do this. Now, of course, we sincerely hope that it does have a mesh, otherwise we might not be in time to create the mesh collider before the player actually steps onto the terrain. So what we'll do is check if our distance has come within the threshold for generating that level of detail mesh, then we'll request it, which is the same thing that we're doing in the update terrain chunk method, except we're going to do it more urgently for the level of detail that's being used for the collider. Now, I'm quickly going to go down to the level of detail info struct, and I'm just going to create a accessor here, a public float called square visible distance threshold, which simply returns visible distance threshold multiplied by visible distance threshold. Okay, so over here in our update collision mesh, we can say if the square distance from viewer to edge is less than detail levels with an index of collider level of detail index dot square visible distance threshold, then if the level of detail mesh that we're using for our collider, if that has not yet requested a mesh, so if that's not true, then we will ask it to request the mesh right away, just by calling in request mesh and passing in the map data. Now, none of this, of course, has to happen once we have set the mesh collider. So let's just have a little bool up here, has set collider, and we will set that to true when we set the collider, and we'll only do any of the stuff in this method if we have not yet set the collider. Alright, now if we save this and go into Unity, and I'll just make the game view a little bit bigger, this is not quite going to work yet, and the problem is just that we're only updating the collision mesh if the player moves. So if the player remains still right at the start, then that first collision mesh isn't going to be added. So what we can do to get around this is make it so that the update collision mesh method is called when the mesh data is received for a specific level of detail mesh. Now, currently the level of detail mesh class has got a update callback, which is just being set to call the update terrain chunk method. But now we want to include the update collision mesh method as well. So we're going to have to turn this into an event so that we can add both of them to it. So let's create public event. All right, so we'll no longer be setting this directly in the constructor. Instead, up in the terrain chunk constructor, when we're looping through all of the level of detail meshes, we can just say level of detail meshes with an index of I dot update callback plus equals the update terrain chunk method. And then if I is equal to the collider level of detail index, then we'll also want to add the update collision mesh method. So level of detail meshes with an index of I dot update callback plus equals update collision mesh. All right, and let's just remove this from the level of detail mesh constructor there, since that no longer exists. And we should now be able to play this and have some success. So hopefully we will land on the mesh. And if I just run around quickly, it appears that we do continue colliding with new terrain chunks, so I'd say the implementation is working. Now, even though the colliders are being set far less frequently than before, there is still, of course, that noticeable pause when one is being set. The only way we can really cut down on this time is to make the mesh chunks smaller. So we'll now be setting up an easy way of controlling the mesh chunk size. So the chunk size is currently stored in the map generator script in this map chunk size accessor, and we're using a value of 95 if flat shading is enabled, otherwise 239. Now remember that the values that we use here are constrained by two factors. First of all, they can't be too large, otherwise we'll exceed the maximum allowed number of vertices in a single mesh. And they also have to be compatible with our level of detail implementation. Now, we're currently supporting 7 different levels of detail, and it turns out this means we have very few options for the size values we can use. However, if we turn the number of supported levels of detail down to just 5, that will give us a much wider range of options. So I'm going to go into the mesh generator, which is of course where the level of detail mesh simplification actually takes place. And I'll define here a public constant int, number of supported levels of detail, and I'll set that equal to 5. So that means that we can have a level of detail of 0, 1, 2, 3, or 4. So in the endless terrain script down here in the level of detail info class, I'm going to constrain this level of detail integer between 0 and 4 using the range attribute. So this should be between 0 and mesh generator dot num supported levels of detail -1. Okay, and might as well do the same thing in the map generator on this editor preview level of detail. So it's between 0 and mesh generator dot num supported levels of detail -1. So if we just have a look quickly, this means that the editor preview level of detail goes from 0 to 4, and on the detail levels here, these also now have a range of 0 to 4. Now, if we look at how our mesh simplification increment is being calculated over here, we can see that within the range of supported levels of detail, it can have a value of 1, 2, 4, 6, or 8. And our map chunk size, +1, has to be divisible by all of those numbers in order for it to work. And it also can't be greater than 96 if we're using flat shading, and it can't be greater than 240 if we're not. Now I've generated a list of all the numbers that meet those criteria. So I'm going to go into the mesh generator and create a public static read-only integer array called supported chunk sizes. And I'm going to leave out 0 and 24 because those are too small to be useful, but I'll add in 48, 72, 96, 120, 144, 168, 192, 216, and 240. Then I'm going to duplicate this and call this the supported flat shaded chunk sizes, which is going to be all of these up until 96. I would, of course, like to declare these arrays as constant, but since that's not legal, the closest we can get is static read-only. Now I also want to make a public const int for the number of supported chunk sizes. So it's going to be equal to whatever the length of this array is. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's equal to 9. And a public const int number of supported flat shaded chunk sizes which is just equal to 3. All right, then in the map generator, we can have a public int called something like chunk size index, and this will be clamped to a range of 0 to mesh generator dot number of supported chunk sizes minus 1, and we can then duplicate this and call this flat shaded chunk size index, and just change this to number of supported flat shaded chunk sizes. Then when we're asked for the map chunk size, we can return mesh generator dot supported flat shaded chunk sizes with an index of flat shaded chunk size index, and over here mesh generator dot supported chunk sizes with an index of chunk size index. Now don't forget that we need to subtract 1 from each of these values, just like how earlier this was 95 instead of 96, and this was 239 instead of 240. I'm going to admit a terrible thing, which is that I don't actually remember why we have to do that, but definitely explained it in one of the earlier episodes, so maybe someone can remind me. Anyway, we save and go into Unity, and we should now have this tiny little terrain chunk, and if we increase the chunk size index, then of course the size of that chunk increases accordingly. And this should also be compatible with all of our different levels of detail. So that's nice. Let's try this out with a chunk size index of about 3. Actually, before I enter play mode, I'd just like to change my distance threshold a little bit. I'm going to bump this up to 400 and 600 and finally 800. And I'm also only now realizing that I forgot to actually remove the use for collider option from the detail levels. So I'm just going to delete that variable now. And then can enter play mode. And as you can see, our terrain is made up of all of these smaller chunks now, which should mean that as I run around, the physics system is having to bake collision meshes with far fewer vertices, and so overall should have a much smoother experience. Okay, there's just one last thing that I'd like to do this episode, and that is to change the way that this terrain chunks visible last update list works. So just to remind you what that's doing at the moment, when a chunk updates itself, if it finds that it is visible this frame, then it adds itself to that chunk's visible last update list. Then when we're going through and updating all of the visible chunks on the next frame, we go through all of the chunks that were visible last frame and we deactivate them, and afterwards that list is cleared. The reason we do this is because we're only updating the chunks in a finite area around the player. A chunk that is visible one frame and then out of range the next frame won't get a chance to deactivate itself, since the update method will never be called on it. So this is an important aspect of our code, but it can be handled a little bit better. So I'm going to start by renaming the list to simply visible terrain chunks, and I'm no longer going to clear the list with each update. Then in the update terrain chunk method, I'm going to create a bool called wasVisible, which is just equal to whether or not the chunk is currently visible. And we're only going to update the visibility if wasVisible is not equal to currently visible, so if the visibility has changed. And then I'm going to say if currently visible, only then will we add this chunk to the list. Otherwise, it's actually going to remove itself from the list. So visible terrain chunks dot remove this. Okay. Now, back up in the update visible chunks, instead of just going through all of these and deactivating them, we're instead going to update them. Now, one thing we have to be careful of course, is that when we update it, it could no longer be visible, in which case it's going to remove itself from the list, and we're going to get all sorts of index errors here. The trick here is to start at the end of the list and count backwards, so that even if a chunk removes itself from the list, we're no longer iterating over it. So I'll start at I equal to visible terrain chunks dot count minus 1, while I is greater than or equal to 0. We will decrement I by 1. Okay. Now, currently we might update a terrain chunk, and then in this block of code over here, we might update it for a second time. So I'd like to be able to keep track of which ones I updated here so that I don't have to worry about them again. So what I'm going to do is, in the terrain chunk class, I'm going to create a public vector2 called coordinate. And in the constructor, I'll just set this dot coordinate equal to coordinate. And then at the top of the update visible chunks method, I'm going to create a hash set of vector2s called already updated chunk coords. Set that equal to a new hash set. All right, and for each terrain chunk that we update, going to say already updated chunk coordinates dot add that chunk's coordinate. All right. So now inside of these two loops, we can say if not already updated chunk coordinates contains the chunk coordinate that we're about to update, only then will we actually update it. So in other words, only if we have not already updated this coordinate will we bother running this code. Great, so if we try this out now, just for fun, let me try this out with flat shading this time. So if we try it out, probably won't see any noticeable performance increase, but just verify that things are still working, that I haven't inadvertently broken something, and it appears that everything is still fine. All right, so that is going to be everything for this episode. Until next time, I guess. Cheers.